Hi students, in this video we're going to be looking at 1.07 number operation properties. Basically in this lesson we're going to be learning about some laws and a good strategy to help us with some maths problems. Now before we begin, this can sometimes seem like a very complicated piece of the topic because we hear that word law and it can seem very scary. But in actual fact, for the most part, we're actually just giving names to things that we've already been doing. So a lot of this we've already been working on, even in the last couple of sections, 1.1 to 1.6, but we're just now giving them names and hopefully understanding a little bit more about why it works as opposed to just doing it. So we'll start by, as always, looking at the lesson. I'm not going to read through it as always, word for word. I'm just going to skip through and give my version of a summary. Now, I'm going to skip the first law actually and go to the second law that they've listed because I feel that they build on each other. So this one's called the commutative law, okay? And we've been using this in our classwork quite a lot already because we know that if we've got two numbers being added or two numbers being multiplied, that we can swap them on either side of the symbol or the operation, being the plus or the multiplication symbol, and we get the same answer. So for example, here in the example, we have 4 plus 3 is the same as 3 plus 4. We can swap the numbers on either side of the symbol and still get the same result. Same with multiplication. 4 times 3 is the same as 3 times 4. You can swap them on either side of the multiplication symbol. However, we also know that it doesn't work for subtraction. So 4 minus 3 is definitely not the same as 3 minus 4. And it also doesn't work for division. 4 divided by 3 is not the same as 3 divided by 4. So we've already been using the commutative law. We just didn't have a name for it. So now you do. It's called the commutative law. So if you have two numbers being added or two numbers being multiplied, you can swap those numbers around and still get the same result. So that's the first law we'll look at. We will now come back up to the one they listed first on the screen, and we'll talk about the associative law. Now, the associative law basically says if you've got more than two numbers being added or more than two numbers being multiplied, you can swap them around into any order you like. So here we have, in the example, 4 plus 7 plus 3, and we can change that into any order. You can 4 plus 3 plus 7, 7 plus 4 plus 3, any order that you like, and you'll still get the same result. And again, it's building on the commutative law. Because we can swap additions and multiplications around, we can put them in any order. Now, it only works if they're in a group together. So you couldn't have 4 plus 7 minus something plus 3 and just move the plus 3 wherever you felt like, because that may not be correct. Okay, so if you've got three or more things like this where they are added together or they're multiplied together, then you can use the associative law to rearrange them. And just like before, it does not work with subtraction. So even if you've got three subtractions in a row, it doesn't work. And if you've got divisions in a row, again, it doesn't work. So for addition or multiplication, multiple things in a row like this, you can use the associative law to just rearrange them. And that might make it easier because the numbers are easier to do in your head for any sort of mental math, or it might just be that you can quickly calculate them on paper quicker as well. So rearranging or move them around using the associative law can help us make the equation seem easier. Let's scroll down again. And again, I'm going to skip over this third thing. I'm going to come back to it. And I'm going to go down to the third law that they're listing. Now, this one can seem the trickiest because there's a few parts to it. So again, it's building on what we've already talked about, and it's called the distributive law. Now, this distributive law basically says if you have a number multiplied by something in brackets that's either added or subtracted, then you can distribute that multiplication. Let's see if we can try and understand what I mean by that. So here's the example. We've got a 5 plus 2 in the brackets, and it's been multiplied here by 3. Now, we can distribute that multiplied by 3 into each value. Okay, so what we can end up with, like we said over here on the right-hand side, is 3 times 5, so 3 times the first value in the bracket, there it is, plus 3 times the second value in the bracket. There we go. So 3 times 5 plus 3 times 2. So we are distributing the multiplication into the bracket. Okay, still added, or it could be a subtraction. So this could be 5 minus 2. So it would end up with 3 times 5 minus 3 times 2 if it was a minus in the bracket. Both of those situations work. Another thing to realize is the 3 times could have been on the right hand side of the bracket, and it would still be the same, because as we saw earlier, if we go all the way back up here to the commutative law, we can swap values on either side of a multiplication and you get the same answer. So here in the distributive law in this example, if we had them multiplied by 3 here, it would still be the same as this number, whatever that is, multiplied by 3. So we've still got the same equation. So we can move it on this side if it makes it easier and say 3 times 5 plus 3 times 2. And if it's a subtraction in the bracket, we can also do that. Where it gets even more tricky, if you like, is that we can also use the distributive law with a division, but only if the division is on the right-hand side of the bracket. And again, the reason we can't just move it is, again, based on what we saw before from the commutative law, is that you can't rearrange divisions. You can't take on either side of the division symbol and swap the numbers over. So we couldn't say this number divided by 3 is the same as 3 divided by this number in the brackets. So it has to be a division after the brackets. So if we look down here, there's an example of that, okay? 24 plus 6, so it's an addition in the bracket. It could also be a subtraction in the bracket, divided by 2. The division is on the right-hand side of the bracket. In that case, we can still do the same thing. 24 divided by 2 plus 6 divided by 2. That will still give us the same answer. But we cannot move it or do it if it was here. If it was 2 divided by 24 plus 6, that would not work. We could not do 2 divided by 24 and 2 divided by 6. It would not give the same answer, okay? So the distributive law can be used with multiplication on either side of the brackets, so long as what's in the brackets is addition or subtraction, and it can also be used for division only in the situation where the division is on the right hand side of the bracket, and again it still has to be either an addition or subtraction inside the bracket. Okay, I hope that makes sense. This is an example of all 3 possibilities you could have. So yeah, hopefully that's making some sense to you. There's some graphical ways here for you to look at them, and again, if they work for you, feel free to use them. Sometimes I find them to be more confusing than just the math, but again, I'm in a different place than you are right now, so you might find these more useful. So please, as always, read through this carefully yourself and take from it the parts that make it easiest for you to understand. Okay, that's a little bit longer than the normal explanation because these can be a bit tricky. Oh, I almost forgot. We did have one more thing. We have reordering. Now, reordering is not a law, not like the other 3. It is just a strategy to help us with our mental math a little bit more. So basically what reordering says is that you can take numbers that are going to be added together or are going to be multiplied together, okay? And you can basically readjust them or move them around to make them easier to do in your head. Okay, so basically if you take, for example, this one here where you have 13 plus 8 plus 7, adding 13 and 8, sorry, 13 plus 18, I said 13 plus 8, didn't I? 13 plus 18 plus 7. 13 plus 18 is harder to do in your head because we're going to have a carry, aren't we? 8 plus 3 is going to give us 11, which we're going to carry that up, and it's a bit harder. But what we can do is, because these are the same operation, okay, they have to be the same operation, we can then move this plus 7 instead to be the next operation. And the reason we would do that is adding 7 to 13 is easier. 7 plus 3 is a nice round 10. I know in some primary schools we call them pairs or buddies to 10. So it's easier for us to do that than it is to add 8 and 3. Okay, so we end up with this version of the equation, 13 plus 7 plus 18. They're all still there and they're still the same symbols or same signs, but 13 plus 7 is super easy, that's 20, and adding 20 and 18 is easy because we can add the 10s easily to get to 30 and the 8 to make 38. Okay, so it's just a strategy to help us with making it easier to work things out in our heads. Okay, so have a read of that in a bit more detail if you like. They do talk about not moving the first number, and it says it down here. So we keep the first number, and then we're looking for which of the other values we could reorder to make the operations easier for us to do in our head. Okay. So that's basically reordering, and it is a very good strategy to help with mental maths especially. All right, we're up to 10 minutes for this video. It is going longer than I like, but we do still need to do our sample questions. So let's scroll down here and have a look at this first question. So the first one says, consider 27 plus 48 plus 13, and which pair of numbers will be easiest to add together first. So we're looking to use the reordering strategy that we just saw before. So 27 doesn't move, it stays at the front. They're all additions, so we can use reordering. So which one would be easiest to add to 27, the 13 or the 48? Well, again, I'm looking at that 7 and 3 and going, they're really easy to add together to get to a value of 10. So I'm going to go with 27 plus 13, so this one, option C here, as the easiest option. And let's see if we're correct. And yes, we are. So now it wants us to fill in these boxes to actually do all the working out. And this is what I would expect to see in your workbook, for example. So I'm going to reorder this to make it easier for me. So 27 plus 13 is going to be my second value. And then of course it has to be 48 there. So I've applied the reordering to get this version of the equation. Now I'm going to evaluate the first addition. So I'm going to evaluate 27 plus 13. Now, because we're specifically doing mental maths right now, I don't have to do a vertical addition over here. So 27 plus 30, well, the 3 and the 7 add, as I said before, easily to be a 10. So then the 20 plus a 10 I just got is 30, plus one more 10 from the 13 is 40. So that becomes 40 and 48 that we still had here. And of course, this is now easy to do, 40 plus 48. Well, the 40s add together easy to give me 80, and we have the 8 left over here. So we end up with 88. So let's press submit and see if we're correct, and we are. So we applied reordering first of all to make it easier to do in our heads, and therefore we were able to do that more quickly. Let's scroll down, and again, unfortunately, we've got to scroll every single time. It just always takes us back to the top of the page, which is a little bit annoying. And let's have a look at question number 2. Now it says, consider 67 minus 38 minus 17. So which of the following expressions is equal to 67 minus 38 minus 17? So if we have a look at the options, 67 minus 17 minus 38. Is that the same? Well, we have two operations that are both the same, so they're both subtractions. So we could apply reordering here. Did we keep the first value in the right place? Yep, 67. So that stayed. If we take away 17 and then still take away 38, does that work? Yes, it does. So I believe the correct answer in my case here would be A. But let's just have a look at the other ones quickly and see why we think it's A. So the second one, second one here, B, we've got 67 minus 38 minus 17. Well, that looks the same, except for we've got the brackets. Now, as soon as we added these brackets here, we ended up working out what 38 minus 17 was, and then taking that answer away from 67. And we know that's not going to give us the same answer, okay? Because 38 minus 17 will not be the same as taking away 38 and then taking away 17 more. So that one absolutely can't be correct. C, straight away I know it's wrong because we've suddenly got this multiplication symbol. We have no multiplication symbols, and there's nothing that we would normally be able to do to two subtractions that would suddenly give us a multiplication. So I'm ruling that out without even thinking much harder about it. And the same thing down here. They're trying to trick us into thinking that we used the distributive law, but we can't. We can't suddenly multiply 67 by 38 and 67 by 17. That just doesn't even make sense to me. So straight away, I would have ruled out C and D without too much thinking. Thought a tiny bit about B until I realized, nope, brackets would mean this is a different number. And then I would have realized that A is the only option, and it looks the way it does because we used the reordering strategy. So let's submit and see if we are in fact correct, and we are. And look what part B was. It says, which of the arithmetic rules can we apply to actually get the answer that we chose up above? And in fact, it is reordering that we just said. Now they've called it a rule here, but it's not really a rule. And again, they didn't say rule here or law, but it's something that we follow. So reordering was the correct answer there. And I'm sure, yes, we are marked as correct. Let's close that one and have a look at the third of the 4 options. Again, sorry, got to scroll all the way to the bottom here. And question number 3. Let's try that problem. So consider 6 times 17 times 5. Now, which of these pairs, so again, we're talking about using the the reordering here, because they're the same operation times and times. So 6 times 17 times 5, which of those would be easiest to multiply together first? Well, I don't know about you, but I don't know my 17 times table. But I do know my 5 or my 6s. So if I multiply 6 times 5 first, I think I'm going to find that easier. Okay, so I'm going to say 6 times 5 is the best option for me here. Submit that, and I am correct. So now let's actually solve it again. This is the working out I'd like to see in your book. So 6 times 5, I said, and then of course we've still got times 17, and that's by using, as we said before, the reordering rule or idea to make it something easiest for us to do. So now we have to evaluate the first multiplication because it is on the left-hand side and we're following BODMAS here. So we've got 2 multiplications that have the same importance. So now we're going to start by what's on the left-hand side. So 6 times 5, of course, either with my 5 or my 6 times tables, I know is going to be 30. And we have the multiplied by 17 left. Now, we've got one more step that wants to fill in the answer to that. And I could go over and do 30 times 17 as a vertical multiplication, and that's perfectly valid, but there is another trick we can use here. One of our numbers, at least, is a multiple of 10. So when you have multiples of 10, you can basically ignore the zeros and just use the numbers left. So in this case, I've got 1 0 I can ignore for a moment, and I'm just going to have the 3. Now 3 times 17 is a little bit easier to do. So 3 times 10, the 10s of 17 would be 30, and 3 times 7 would be 21. So therefore we've got 30 and 21 would give me 51. All right, but we're not finished yet because we technically ignored this 10 before. But to bring it back in is simple. We just add it on the 0. So a multiple of 10 can be ignored for the moment, and then we can add the zeros back in. If this had been 300, we could still ignore both zeros and then put them both back in at the bottom. It's a little trick for doing quicker mental maths with bigger numbers. If you've got a multiple of 10, you can ignore the zeros, use the numbers you have left over, do your multiplication or whatever, and then you can add the zeros back in there. Okay, it works for multiplication. So my answer here would be 510. There we go, we can see we're correct. Let's close that one and go one more time to the bottom of the page. Here we go. And we're going to have a look at the last question, question 4. We're hopefully going to bring all this together and try a detailed example. Let's have a look at it. So we're going to consider 168 divided by 7. So we're going to fill in the box to complete this sentence. 168 divided by 7 is the same as 140 plus something divided by 7. Now what are we doing here? Why have we broken up the 168? Well, the reason we're doing it is we're trying to find numbers that will be easier for us to use the distributive law to solve later on. And I'm guessing it's distributive law because our division is on the right-hand side of my brackets. Okay, so I'm basically building an equation that is easier for me to do. So 168 is made up of 140 plus something else. What do we need to add here? Well, that's going to be 28. Some of you might already be realizing why we chose 140 and why we chose 28. The simple reason is they are easy numbers to divide by 7. Okay, but let's go through the steps and see what else it wants us to do. So we've now basically created, this is still the number 168. We've just broken it into 2 values that we can easily use. And I'm going to guess we're going to be using distributive law in a second to work this out. So let's submit and look at part B. So now it says fill in the box to complete this sentence. Yes, we have used the distributive law. So what we're saying is 140 divided by 7, there it is there, plus, because inside the bracket is a plus and our division is on the right-hand side. Remember, it would not work if it was 7 divided by this. It has to be on the right-hand side for division. So this becomes 28 divided by 7. We have used a distributive law to write the equation like this. And again, this might seem like, why are we bothering? But really it's all coming down to being able to do this more quickly in our heads without having to always get our calculator out in this particular case. So lo and behold, it's actually asking us which law we used to get the answer before. And I've said it about a dozen times, it was a distributive law. So let's submit that option. And finally, it wants us to solve it. So again, like we saw before, we are going to use that little trick similar before with the first numbers, 140 divided by 7. Let's ignore the 0 for a second because it's a multiple of 10. So now we've got 14 divided by 7. And we should be able to do that super easy, and that is 2. But we have to add back in the 0 that we ignored, so it actually becomes 20. And on this side, 28 divided by 7, again, that should be really easy because we know our 7 times tables. So 28 divided by 7, or the other way to think of it, of course, is what multiplied by 7 gives you 28 would be the value, oops, sorry, wrong box, would be the value 4. So now we've ended up with 20 plus 4, which of course is super easy to solve, to be 24. So we've gone from a complicated division, which we could obviously go and do a short division or even long division to solve, and we will still get to the same answer, but by applying some laws and rules to make it an equation that's actually easier to solve for us, we can get to that answer a little bit quicker possibly. Both options would be completely valid, and the main reason we're doing it this way here, of course, is to practice applying and understanding these laws and rules. So let's submit and make sure we were in fact correct before we go any further. Yes, we were, and that will be it. So, as I said at the beginning, this can seem like a scary topic section just because we use the word laws and rules, because they're a bit big, associative, commutative, and distributive. They seem like scary words, but really, for the most part, it's things we've been doing, and it's just giving names to them. Have a good practice of these. Try and remember those terms. There is a little list that you can print out that's on our Schoolbox page, and it might be worth printing and sticking in the front of your book or something as well, or somewhere that you can easily access it to help you remember some of these laws. Okay, you might also want to make your own notes to help you really understand them. They are terms that you will have to learn over time, and they will pop up again throughout other parts of Mathspace throughout this year and going forwards. But as always, go back and read this if you need some more time. Do the questions to practice. Ask for lots of help. Don't think you have to suddenly remember these straight away. They're things that you'll develop and learn more over time. So good luck with the questions. Make sure you, as always, start with the lowest questions and work your way up, and have a good go at all of them before you ask for some help and get that if you need it. Again, this was a longer video, so my apologies. If you've made it this far, well done, and I'm hoping that you have in fact been able to understand this.